Hey, this is East with Journey to Programming. Today what I'm going to talk about is UDP versus TCP communications over IP. So, really quickly, most of you guys may be thinking, what the hell is he talking about? What is TCP? What is UDP? Well, what these acronyms stand for are, for UDP, User Datagram Protocol, and for TCP, you're looking at Transmission Control Protocol. So both of these are protocols for communicating data over IP. IP stands for the Internet Protocol. So most of the time when you're communicating data over the Internet, you're going to be communicating using either TCP or UDP. That is the most common methodology for communicating data back and forth. The way you communicate data over the Internet using UDP and TCP is you basically bit pack the data and then you send it over a message which we call a packet. Okay? So let me go ahead and just really quickly explain what the differences are here. So when you use TCP, you have reliable data transportation. So what you have with TCP is you have a guarantee that the messages you send will be received by the other endpoint in order, and each packet that gets sent will be acknowledged by that recipient. So what your computer can do is it could say, hey, I'm sending a TCP packet over. Once you've received it, send me an acknowledgement so that I know to move on to the next packet in my queue of packets to send. If you don't acknowledge, I'm going to try resending until I time out, at which point my TCP sending will stop. In most cases, you're going to get an acknowledgement and you're going to continue. This guarantees reliable transportation of your data over TCP IP. Now, UDP, on the other hand, eliminates all of that validation, all of the error checking, and all of the reliability. So what ends up happening is when you're sending a UDP message or a UDP packet, you're just going to send it out there to the endpoint. You don't know if they received it. You're not waiting on any acknowledgments. You don't care. What you're going to do is you're just going to continue streaming UDP packets. And the beauty of that is in speed. So both UDP and TCP protocols have advantages and disadvantages. In situations, for example, like loading up a browser on your computer and trying to connect to a website, you're going to want to use a TCP packet to send a request, tell that website, hey, I'm trying to load you up. Can you send me the data to display a web page on my browser? And they're going to respond either yes or no. If their server's on, they'll most likely respond yes. They'll stream the web page packets over with the data. Your browser will then interpret it and display what you see as a web page. So that is a case where TCP is great. You want the packets to come in order and you want the acknowledgement when an event occurs. So when you click on a link on that web page, you want to definitely and reliably send that packet over TCP, get the response, and then have the server send you that appropriate data back. Now, in a case where you're playing a game, for example, TCP in real time would not be the choice you'd want to make, because most video games, especially online games, really push and emphasize real-time playing with low latency. So what we can do is we can use UDP. By using UDP, we eliminate that validation, like I mentioned earlier, and we just stream out packets. So in an online game, imagine a massive online shooter or an FPS game where we don't care about packets that have been missed. We don't want to rubber band back to an old character position. Instead, we just want to stream the most up-to-date information. In that case, we would use UDP, although there may be cases where we have missed packets. Usually it's rare unless the server or web, some internet issues are occurring on either party's end, but those kind of have minimalized over the years. So what will end up happening is you'll just stream out all of your current player data, and the server will receive that. If it doesn't receive it, or if it receives part of the packet, it'll keep on going. It'll just keep on pushing out data and sending it out to other users, so they get the most up-to-date information. The drawbacks to this could be that you may skip, or you may what we call in the gaming world teleport in some instances, because maybe you're moving forward, but you missed a few packets, they finally get received on the server end, and you're 20 steps ahead of where you just were, because there was some sort of hiccup in the transportation. In a gaming world, we would want to just skip those missed packets and continue on in real time. So that is where the advantage of UDP would occur. So once again, let's just go back over what we just said. UDP packets eliminate the latency due to the acknowledgements which TCP would require. So TCP is a reliable transportation method which requires each packet to be acknowledged before continuing on with the next sequential packet. So now what I'm going to do is I'm going to end this video here, and stay tuned for an update where I'm actually going to be showing you how to do TCP and UDP communication, and I'll show you guys how to code that up. Until then, have a good one. This is Isa with Journey to Programming.